Hello, and welcome to today's daily Leetcode challenge. Today we'll be solving question 880, decode a string at index. I'll be walking through my thought process as I come up with a solution, or later you'll see in this case I actually didn't the first few times. Then stick around for the end of the video where I compare my solution to the solution of others on Leetcode. With that, let's begin question. So we're given you're given an encoded string S to decode the first to a tape, to decode the string to a tape. Okay, pretty simple at this point. The encoded string is read one character at a time, and the following steps are taken. Okay, so we're given a string. It's encoded in some way. We have to decode it. These are the rules. If the character is read, if the character is read If the character that's read is a letter, so we know that there's going to be multiple types of characters, the letter is written onto the tape. However, if the character is read as a digit, the entire current tape is repeatedly written d minus 1 times. Okay, so if for example, d minus 1 times, d digit. So, okay, so what does this look like in some examples? Given an integer k, return kth letter, which is 1 minus indexed in the decoded string. Okay, so all of that is pretty clear. We're given some decoded string, and we have to figure out we're given some encoded string. In the decoded version of that, what is the kth letter? And as an example 1, we're given Leetcode 2, 3, and k is equal to 10. So what does that look like when we decode it? It looks like we're going to be reading leet 2 code 3. So leet, and then since the next character is 2, we repeat that 1 minus indexed. Sorry, no, we repeated d minus 1 times, so we repeat this another time. So we write leet again. And then we have the next character is code, right? Code. And since after code, the next character is a 3, that means that we repeat the whole thing 2 more times, d minus 1 times. And that essentially means that I'm going to essentially just duplicate it. We get 1 and then another um, 1. Cool. So that would be our decoded string. And now that we have this whole thing decoded, we have to find the kth, which is the 10th character. So we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there we go. O is the response. Beautiful. Okay, so all of that makes sense, to me at least. There are some other situations in these examples here where you're, for example, given H, A, and then 2, 2, in which case this is essentially just H, A, and 4, and you could translate that into H, A, H, A, H, A, H, A, H, A. It would be the same thing if you were to do the first H, A just twice and then repeat H, A, 2 more times. So there are some optimizations that could be done there. However, the solution for me was not at all obvious, and I actually ended up solving this with a timeout issue, which I'll tell you right off the bat, I solved it in O, what was it? Not OK. I solved it in O, whatever number this is. So in O len of the decoded string, which is which is not okay because this number here, if a was repeated this number of times, this essentially means that I have to create a string, a decoded string of that size. So I wasn't actually even using up any extra space, but just this number of operations. This is something in the, I don't even know, 100,000, 1,000, billion. This is like billions. Okay, so yeah. And so that didn't work. I was kind of stunned for a really long time, and I wasn't actually able to figure it out. The way that I solved it was the following. I decided that I can't use up any extra space, right? And so what I did was my first step was to translate the decoded string into an array. Sorry, and the encoded input string, leet to code 3 into an array that looked something like um, LEET to uh, CODE 3. There was some step in here that's not visible in this step, which was if we see something like two integers repeated, we would multiply them. So for example, if right here this was like 2 code 3, then this would end up being 4, right? So just a quick step there. But um, once I get to this situation where I have um, the encoded string as just a bunch of characters, I would essentially a bunch of characters that some are integers that I would run through this k number times um, until I exhausted all of my k's. And so that could have worked, but I actually no the I would have essentially solved the solution in OK. I completely messed up. No, it wasn't O length of the decoded. It was length OK. But even OK, I think ended up causing issues because some Ks were in the order of thousands of billions. And so that didn't work. But turns out that all of this can be done O of len S, I believe. O of len S, S being the input string. How that's done, I'm going to go through right now. But yeah, just keep in mind that this is not at all an intuitive solution, and I probably would not solve this if this was on an interview anywhere. Cool. Well, with that embarrassment out of the way, let's begin the explanation. So, um, I'll talk through kind of how we're using some of the variables um, that are going to be needed in this uh, solution. Uh, so the first variable that we're going to be consistently using is the input string itself. So this string itself is for us serves two purposes. Purpose number one is it is a uh, it serves as the how did I say this? Kind of like the control center, but also a a map of what steps to take when we're trying to find kth map of what direction. I would say direction. Then we have oh, and then also it's used in another form of way. It's used um, as the actual place where we find our results. So as you know, like the string, the input string contains um, characters and digits, but we're going to be looking at some of these digits uh, or some of these characters to find the solution as well. So it has two purposes. Then we have another, um, then we have another variable called size. Size is going to be the size of the decoded string. So len of decoded string. This is not the length of the encoded string, which is here. No, this is the length of the full decoded string, as if it's created. Now, what is important here to understand is that although we have the size of it, it doesn't mean that we're storing this ginormous thing anywhere. We're not storing 2 to the however many 2's there are. We're only going to be storing the size, and that's just one number, so that's acceptable. So once, and that's pretty much it. These are the only two things that matter to us: size and the s input string. And we're going to be using all of these needed sort of mechanisms here. So first step is going to be to find the size, and finding the size is pretty trivial. I'm sure that you can write a loop where if you are encountering a character, then you increase size by 1, and if you're encountering a character that's actually a digit, you're increasing the whole tape, the digit number of times. So that's fine. But what is going to be the next step? Well, the next step is going to be we are left with a um, a variable size that represents the length of this len of decoded. We're going to be left with some variable size that that represents the length of this string, decoded string. Now we don't even care about what these characters are going to be yet. We just know that our k is somewhere in the, well, in this case, I know exactly that it's in the 10th, but it could be somewhere in one of these places. We don't know where, right? So I'm claiming that I can find the kth character in this decoded string that I don't even know what it is yet, and I will never know. Well, I will never need to know what it is fully. I just need to know its size in just uh, len s operations. Len s, I'm referring to the input string. So here's what the steps look like for um, for every index in in the range of, or the reversed range of length of s, meaning that it's going to go from, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it just happens to be 10, 5 and 5. Yeah, in length of s, so it's actually just going to go from 9 to 0. I'm going to do the following. I'm going to first say that a variable that I'm calling, let's say, j, a variable j is going to be equal to j modulo size. Now, for example, in the case that we're describing right now, size is equal to 32. Size is equal to 32. What I mean by that is Leet2 code 3. If you actually if you actually count what the length of this thing is, Leetcode, you'll see that 4 times 3 is 12, 4 times 3 is 12, and 12 times 3 is 32. Wait, did I say that right? No, it's 36. It's 36. I just caught myself. Yeah, 12 times 3 is 36. So when we're finding this k, this j, um, actually, I'm just going to call it k. Well, it is actually k. K is 10. We're going to be doing k modulo size, which will just give us 10 for now. We as if we've cut our k, or we've divided k by a huge number, the remainder just happens to be the remainder because k is nowhere close being bigger than size. So k just stays the same. And then I'm going to say the following, that if k is equal to 0, meaning that in some, actually, no, I'm not even going to say that for now. I'm going to, and this step is also confusing, the k modulo size. What I want to do for now is just figure out, using the direction here, the direction usage of s, what to do with my size, what to do with this variable here, lens size. I want to modify it. I'm going to say that if um, the input string I is equal, or is of type is digit, then I want to say that size, which I'm using as to represent this whole thing here, I'm going to say size is equal to size divided by, and this is an integer, divide by the SI. So what does that mean? That means that when we encounter here, when we encounter this 3 over here, we're going to, as a first step, we're going to cut this input string into 3 different sections, and we're going to remove the last 2 portions of it. What does that now mean? That now means that size is just equal to 12. And what does this 12 mean at this point? It means leet code. Leet code. Cool. I have leet code. And by the way, here, if it's not a digit, then I would be just saying that I would just be saying that size equals size minus 1. What does size equals size minus 1 mean? It means that if I'm now encountering just regular letters, regular digits, or regular characters, then I would just be subtracting size by 1. And we're going to be doing that pretty soon. So now that I have leet code, right? I have leet code. See, by the way, how the input string s right here does not at all correlate to what the actual size is pointing to. The size is pointing to a completely decoded string that doesn't have these 2s and 3s and directions in it. And this is what I meant by the input string is going to be used for both telling us what to do with this size, how to divide it, or how to subtract numbers from it based on what it is. And it's also going to be used for the last bit, which I'm going to get into right now. So, cool. I have described how I'm going to modify size based on what is in the directions input string, but I haven't explained, I guess, fully what is going to be happening if we encounter when we actually find the um, what when we hit the kth from this side letter. So for now, I'm just getting k smaller and smaller because the size is getting closer and closer to k. By the way, the closer size is getting to k, the how about this? The first instance that size, and let's say that just purely visually, k represents this value, but size represents this value. Uh, in this case, k modulo size literally just equals k because you cannot divide a smaller number by a bigger number and get a remainder. The remainder is k itself. So k is slowly shrinking. I mean, sorry, size is slowly shrinking one by one. It's shrinking a little bit, a little bit, a little bit until it hits this size, until it hits this k. At that point, k all of a sudden here becomes 0. And once it becomes 0, I have a condition for that. I say that if k is equal to 0, I'm going to essentially um, I'm going to assume that my next character has to be the correct character that I was actually looking for, and I'm going to explain why there has to be a while loop within this if statement. But what I'm claiming right now is that while um, while si is digit, I'm going to say I equals I minus 1, and then return si. Okay, so why do I need this while loop? Because it actually almost seemed like we've figured out that if k is equal to 0, then return the i's, return whatever i's is. But the situation here is that since S actually contains these digits in it, there's a chance that once k is equal to 0, we're still looking at a number, not a character. So this last portion where we are doing a while S is a and digit. I don't know why this, let's say, is digit. Here I said I is equal to minus 1, and at that point, I want to return si. Cool. I hope that it's going to make more sense when we start implementing it, but that is pretty much the explanation. Okay, let's start coding. So the idea was that we were going to have a variable called size. We're going to first populate that size with what the decoded string size is going to be, and that is going to be for C in S if C is digit. And there are some cool Python string methods that you can use. Is digit is one of them. There's another one that's called is alpha, which says that it's an alphabetic. Size is less or equals to int c. So this is what I was saying before, that we're going to do this first step of finding what the actual size is. And then else size is just plus equals to 1. Let's look what size now equals to. It should just be 36, as I said before, right? So this is the decoded length of the string. Now we're going to find our kth character in OK. No, was it OK? In O-len S, I think. Did I say OK before? We're going to be iterating through all of the length of S. So this is going to be big O of len of S. Okay, cool. So for I in reversed range of len S, this will give us something like 35 all the way to 0 inclusive. We're going to say that K is equal to, can I do this? Modulo size. And then if K is equal to 0 while I is digit, I'm going to say I minus equals 1. So this is a little bit, I guess, unorthodox because I'm modifying I within the loop itself, but this is okay to do because I know that once I've hit this K equals 0, I'm essentially returning from this value here as well. So I'm just doing some cleanup. And then finally, if Si is digit, I'm going to be saying size is divided by int Si and else size minus 1. So this first case is that we have encountered in S, in our string that we're using for directions, we've encountered a digit, and we have that ability to get the size all the way down to what the size would have been if we hadn't touched that digit in the decoded. And then in the case where it's just a regular character, like that it's not here, then we just subtract I. We just subtract 1. And that's pretty much it. We're guaranteed to hit this return statement at some point. I like to kind of get something at the bottom as well, just because it looks cleaner. It looks like there's a good finishing point. But yeah, let's see how well we're doing. We're actually, I guess, not doing too well. I don't know why, and I doubt that I'm going to be able to understand what the solution here is, but well, I mean, they're getting this size, and that's the same exact step, and then they're saying that for C in reversed S, which I could do right away. I could do that. Why didn't I think of that? I think I was, yeah, I could absolutely do that. Reversed, we can just claim that this is our character. And then wherever we do that, we're just going to be saying C. And then, oh, I see, this is the only step that's going to mess this up. I could say this, and C is alpha. I'm going to return C. If C is digit, then C, otherwise, okay, this should work too. Alpha is alpha. Is digit is alpha. Let's see how much faster this is. This is a pretty long video. But yeah, this is what they did. I agree. It's a bit cleaner. Um, the reason I was able to get rid of that while statement within that is because I'm going to be hitting it the next time I encounter this while loop, and yeah, I'm seeing that or that for loop the next time I go through that for loop. I see here that it's not actually making this code any faster, so I think that this is just the optimal solution, and uh, we're just uh, we're just hitting the Leetcode, I don't know, deviation of runtimes. So I would say yes, I would say that this is quite a bit cleaner and use this instead of what I suggested before. I hope this made sense. Again, I struggled through this a lot, and even the explanation I feel like could be done better, but it's the best that I got. So thank you for watching, and see you later.